Hi, my Math 130s. So we get to the last part of the homework alternate chapter 7 assignment. Today, I'm going to go over part 4, which is going to cover problems number 16 through 20. In the first part, I covered numbers 1 through 4, and then second part, number 5 through 10, and then 11 through 15. And now I'm going to get through these ones, okay? Let me save a picture of that and clear all this out. So I think I'm going to go back and forth a little bit between the whiteboard and staying on this page, just because I'll have more room on the whiteboard. First question we're covering, number 16. Write the quadratic function in the form f of x equals a times the quantity x minus h squared plus k. Then give the vertex of its graph. So there are a few things I'm going to put on this screen before we move. So this form here we've been talking about for the past few days. This is called a vertex form for a quadratic equation. And since you have a function form here, it's quadratic function. Okay, so remember we also have standard form, which is what's given here. That's the f of x equals ax squared plus bx plus c form. Okay, so what you're being asked to do here to write your quadratic function in this form, that means you need to complete the square. Okay, to go from standard form to vertex form. Let me write form in here just to keep good form. Okay, so this is essentially our goal. And then once we get to vertex form, remember that the vertex is located at HK. So when we have this form, we're going to be looking for H and K. All right, let me save this. And I'm going to start a new share with you. Okay, I guess I have to stop my share first and then start a new one. There we go. Okay, so first thing, we're starting in standard form. Oh, let me write one more thing. This is number 16, homework alternate, chapter 7. Okay, so standard form. Okay, and remember our goal complete the square and get this form. Okay, and then find the vertex. All right, so if you need review on completing the square, definitely go back and watch part 3. Come on. There we go. Watch part 3 from homework alternate chapter 7. I went over a completing the square problem there that's similar to this one, and it'll help you understand the process of completing the square and what to do when you have a coefficient a that's not equal to 1. All right, so here we are. Okay, first thing we're going to do is factor a out of the ax squared term and the bx term. So that's just if it helps you in words, but basically notice that a here is -2. So I'm going to factor that out. And then I'm factoring that -2 out of the x term. So the x squared part and the x. We have -2x squared, divide out -2, you're left with x squared. 16x, divide out -2, you're left with -8x. And then keep your subtract 31 at the end. Okay, next step. We're going to just change our form here. Notice where I'm leaving some space. So let's put this step in green. We're going to be adding some number here from the completing the square process. And we're going to be subtracting the same value that we add to the right side. Basically, whatever you add right here, you also want to subtract the same value right here. So your function stays exactly the same. All right, so remember how we did this last time. We're going to look at this inside quadratic. For the inside quadratic here, we have a equal to 1, b equal to -8, and we're looking for c essentially. Okay, what goes here? B over 2a squared. Okay, so -8 over 2 times 1, the quantity squared, it's going to be -4 squared, which is 16. Okay, now be careful here. What are you really adding to the equation right here? This -2 is distributed in to each term of the quadratic. So you're actually going to be multiplying here, -2 times 16. Okay, so here I have -2 times 16 that I'm adding to my equation. So I'm subtracting the same value from the same side of the equation to keep the equality, all right? So many equals, so many stumbles. Okay, so let's write that out in words. Find b over 2a squared Okay, so the underlined parts that I put here. So we're going to put b over 2a squared. And then whatever value you're actually adding to this side of the equation, you must subtract that same value. Kind of want to find a different way to say this. I don't feel like it's as helpful. I guess I'll just wait. Watch it. Let me know what you guys think about the explanation and if it's very clear. If it's not, I will cover it in more detail. All right, so now next step. We're going to complete the square. By changing our inside quadratic here into a perfect square trinomial. Essentially, you're thinking I'm factoring, okay? So the parts that don't change, -2, the -31, and then from this portion here, we're subtracting a -32. Now, this portion turns into x minus 4, the quantity squared. Okay, let's bring this a little bit closer to the rest of the equation. There we go. All right. So the whole goal of completing the square, you're adding some value to your quadratic and then making that quadratic into a perfect square trinomial by factoring. Okay, so now, next step is just to simplify. We have -2 times x minus 4, the quantity squared, -31 plus 32. That's -2 times x minus 4 squared plus 1. Okay, so, oh my gosh. What did you do? Okay, hold on a second. I have to pause. My cat just knocked something off the counter. All right, well, it's something non-essential, so that's good. All right, back to this. So basically what we found is that our function f of x in vertex form is -2 times the quantity x minus 4 squared plus 1. And from there, we can actually find the vertex, which is located at hk. H is equal to 4 here, and k is equal to 1. Remember, if the signs get confusing to you, you're matching to a times the quantity x minus h. So that's why h is positive here. And then that quantity squared plus k. And that's why k is also positive. Okay, that completes that particular problem. We are done with number 16. We're going to move to number 17 now. I'm going to go ahead and clear my screen. And then stop my share and share with you the notes again. Okay, so number 17 is next. I think that I'll just do this one on this screen. An aircraft factory manufactures airplane engines. The unit cost C, the cost in dollars to make each airplane engine, depends on the number of engines made. If X engines are made, then the unit cost is given by the function here. C of X is equal to 0.5 X squared minus 130X plus 17,555. What is the minimum unit cost? So, and it says don't round your answer. One thing I want to make note of here is that you're asked for a minimum unit cost. The minimum part refers to the vertex. Notice that in pink, we have a quadratic function. Okay, and the a value is 0.5, which is greater than 0. That's positive, right? So we're going to be getting a parabola if we graph. Smiley face, and the vertex is the minimum point. Okay, let's actually make that part in blue. So your vertex is right here. Okay, so now minimum cost. Let's put this in a different color. Let's try yellow. So unit cost, that's a y value. And I know that because c of x, whatever its value is, it's going to be the same as y. And c is cost. Okay. All right, so we're going to find the vertex of the quadratic function listed here. Okay, that's the minimum part. And then your answer should be the y value. Okay, so let's see this in practice. This is standard form that's given. For our quadratic function, we have a as 0.5, b as negative 130, and c is 17,555. Okay, remember your vertex is located at hk, and in standard form, h is equal to negative b over 2a, and k is equal to your function value. Your function in this case is called c. So k is the function value at negative b over 2a. So let's start by finding h. It's going to be negative 130 divided by 2 times 0.5, which turns out to be 130. Okay. This is the x value of the vertex. Okay, which isn't what we're looking for. That doesn't give us our cost. So what we're going to do, find k by plugging in our h value into our function. So c of 130. That's going to be 0.5 times 130, the quantity squared, minus 130 times 130, plus 17,555. Okay, when you plug all that in and simplify, you wind up getting 9105. Okay. This is the y value of the vertex. Okay. So y value of the vertex. And then for finding our vertex, this is the process. All right, let me take a picture of this. I'm going to clear this out so that I have some room to make my conclusion. So essentially our solution uh, 9105, make sure you have units on it. It's cost, so dollars. All right, I'm going to clear this out, move on to number 18. For number 18, we're trying to solve a polynomial equation. Essentially, you have a trinomial multiplied by a binomial. So you have a quadratic multiplied by a linear term. Okay. This particular problem, let's go ahead and put it down here. This is going to be a factoring problem and use a zero product property. ZPP. Okay, so let's do this in some different colors. Let's factor in pink, and then we'll use zero product property to solve for y in blue. Okay, so the first thing is notice that your quadratic is factorable. You could use AC method on that, or you can use trial and error. So y takes the lead. We're going to have plus 5 plus 6. And then for your second factor here, which is a linear factor, we can factor a 2 out, and we're left with y minus 8. Okay, so those factors all multiplied together still equal 0. Let's rearrange so it looks a little nicer. I'm going to put the coefficient of 2 out in the front, and then the binomial factors following. Now we're going to use zero product property. Remember, zero product property states each of your factors individually can be equal to 0. For the 2, essentially, if there's no y term in your factor, you will not set it equal to 0. You can kind of think about this step like I'm going to divide 2 out from each side. And now on the left, I get my 3 binomial factors. On the right, 0 divided by a number is just 0 still. Okay. All right, so ZPP states each factor individually can be equal to 0. So y plus 5 can be equal to 0, or y plus 6 can be equal to 0, or y minus 8 can be equal to 0. So y can equal -5, or y can equal -6, or y can equal 8. So the solution for number 18, y can be -5, -6, or 8. Okay. Always helpful to check for this, but a little hint for you, you don't have any even roots and you don't have a denominator. with y's in it, so you won't have any domain issues. All right, let me save this picture. And then I'm going to clear out the screen. We're going to go over 19 and 20, which will be very similar. And then we'll be done with chapter 7. Next week, I'll be covering chapters 8 and 9. And then that should leave us plenty of time for review and questions leading up to the final. Okay. All right, so let me clear all this out. Number 19, graph the solution to the following inequality on a number line. So you'll be given a number line in ALEKS. You have x squared minus 4x is greater than or equal to 12. So give you some insight. Numbers 19 and 20 are polynomial inequalities. Okay, and they're going to be polynomials that are greater than linear ones. You might remember, for example, we had things like x greater than equal to 5, and we would graph that on a number line. Okay, another example, x minus 2 is less than 0. Okay, before we would say, okay, let's add 2 to both sides, and then graph our solutions on a number line. 2 is my boundary value, hole here. Okay, so remember holes and points. We use a hole when we have a greater than or less than sign. We use a point when we use a greater than equal to or less than equal to sign. Okay. All right, so now essentially we're going to have quadratic and higher power factors here. Sorry, I didn't want to say factors. Let me be careful with my speech here. So we're going to be looking at quadratic or cubic or higher order polynomial inequalities. Okay. All right, so number 19, I'm going to actually flip over to a whiteboard so I have some more space here. Okay, so this is homework alternate, chapter 7, number 19. Solve. Okay, so the first thing I want you to think about for this particular type of problem is if I had x squared minus 4x equals 12, how would I solve for x? Okay, well, remember, I would need to get all of my terms to one side. Right? And then factor or use quadratic equation. Sorry, quadratic formula. Sorry, one more thing. I can say that better. Let me write it out first so it'll be more clear. There we go. Okay, so typically, if you can factor your quadratic, you want to do that first. And then you just use zero product property to solve for x. Or you would use quadratic equation, okay? Why do I still want to say equation for that? Formula, come on, Christine. Okay. So just to emphasize, like a quadratic equation would be one of this form. But quadratic formula is the good old negative b plus minus square root b squared minus 4 ac all over 2a. Okay. So this is actually factorable. I'm going to have x minus 6, x plus 2. And then zero product property. Okay. So that's how we would solve. Now, essentially, for our inequality up here, we're going to start the process the same way. We're going to get all the terms on one side of the inequality. Okay, so x squared minus 4x minus 12 greater than equal to 0. And then if we can, we're going to factor. Okay. We're still going to need to know when x is equal to 0. So we'll use ZPP, but that's going to help us to find our boundary values. So the boundary values would still be the same. X equals 6, x equals negative 2. Now, in the next step, be very careful here. You're going to want to say, and let me put this in red so you know it's wrong. You're going to want to say, oh, x minus 6 can be greater than or equal to 0, or x plus 2 can be greater than or equal to 0. So and then when you plot it, you're going to say, okay, so here's my negative 2, here's my 6. Okay, I'm saying x can be greater than or equal to 6, or x can be greater than or equal to negative 2. Okay, no. Okay, you can't do that. I'm going to save a picture of that and erase that piece. What we need to do, put this in green so we know we do it, is make a number line. And test x values, test points, to check for sign from original inequality. I know that's a lot to take in. It hopefully will make more sense after this next step. Here's our number line. These are our x values. We're going to put our boundary values on there, negative 2 and 6, in the correct order. Okay, now If you see a greater than equal to or less than equal to in your original inequality, you are going to have points at your boundary values. Okay. If you were to have a less than or greater than sign strictly, you would have holes there. Okay. All right, so then the test points come in. That just means choose X values and then test for the signs. Technically, for your original inequality, you'd plug in there and check. But I'm going to teach you a little bit of a shortcut that involves the factored form. Okay. All right, so let's choose our X values first. For this first section, let's choose X to be -10. For the middle section, let's choose X to be 0. For the last section, let's choose X to be +10. Doesn't matter what the numbers are. We're actually just going to use signs to help us here. Okay, so you see how when we moved all the terms over to the left side and we factored down, we have a binomial times a binomial. And we're saying that whatever this binomial times binomial comes out to be, we want it to be greater than or equal to 0, meaning positive or 0. So if I were to actually plug -10 in to this shortened form, -10 minus 6 times -10 plus 2, is that greater than or equal to 0? Okay, this would be -16 times -8 . That's going to come out to 128, which is greater than or equal to 0. So it's true. Okay. Let me save a picture of that, and then I'm going to clear the bottom. If you check it in the original, it works as well. But shortcut, check the signs from star. Let's call this star. If I plug in a -10 for X, my first factor would be a negative. My second factor would still be negative if I plugged in -10. A negative times a negative is positive, which is indeed greater than or equal to 0. Okay, so this side will be true. Okay, let me actually just keep it in purple. It'll look more consistent. Okay, let's check if X is to be 0. Again, let's just use the shortcut here. If I plug in 0 for the first factor, I get a negative. plug in 0 for the second factor, I get a positive. So that gives me a negative, which is not greater than or equal to 0. So this part would be false because it's negative. Okay, then if we plug in 10, positive, positive. Which gives me a positive out, which is indeed greater than or equal to 0. So we use this side as well. So you're asked for a number line for number 19. This is what you would want your number line to look like. Okay. All right, that covers number 19. Number 20 is going to be very similar. Main problem with number 20 is we are starting off with a cubic function. So let me go ahead and stop my share after I clear this out. Go back to the notes so you have a refresher. Solve the inequality. We have x cubed minus x squared greater than or equal to 9x minus 9. Write your answer as an interval or union of intervals. So what that means is just interval notation. Okay. And if there's no real solution, click on no solution. Okay. So essentially, what we're going to be doing is starting this problem off the same way. Get all your terms over to one side. I'm going to move them to the left. And then we're going to see that we can factor this down. All right, save that. Stop share, go back to whiteboard. Okay, this is a homework alternate. That is so ugly. Alternate chapter 7, number 20. Okay, so there's my original, sorry. There we go. All right, so first step. Get all terms to one side of inequality. So you should have 0 on one side when you're done. I'm going to subtract 9x from both sides and add 9 to both sides. Okay. Step 2. Attempt to factor by grouping if you can. I'm like hating my writing today. So I'm going to shorten it, attempt to factor if possible. If it was a quadratic equation, a quadratic inequality, then you would factor similarly to how we did in the last problem, AC method. If you have more terms, you want to try to factor by other methods. For this, we have 4 terms, so that's why we are signaled to factor by grouping. So there's my first group, second group. I'm going to factor out x squared. I'm left with x minus 1. I'm going to factor out a negative 9. I'm left with x minus 1. Okay, a good way to check, distribute back, you should get this left side here. Okay, so now remember, we have a GCF of x minus 1. That's common. And then we have this left over. Now, sometimes you'll be done with your factoring, sometimes you won't. Hopefully you can tell that we have a difference of square in here. This will be x, the quantity squared, minus 3, the quantity squared, which turns into x plus 3, x minus 3. Okay, you could skip showing this step right here. You can go from here to here. It's fine. Okay, same thing. Don't use zero product property to actually split your inequalities into 3. Just use zero product property to figure out what your boundary values are. Okay, so again, just in red to make sure what I mean by this, don't say, okay, x minus 1 can be greater than or equal to 0, or x plus 3 can be greater or equal to 0, or x minus 3 can be greater or equal to 0. You can't do this. Okay? Okay, so what we find here is that if we change that inequality sign to an equal sign, and we use ZPP, we would get x equals 1, or x equals negative 3, or x equals positive 3. So our boundary values that we're going to put on our number line clearly marked will be negative 3, 1, and 3 for x. Let me save a picture of this, and then I'm going to clear out the first few steps. All right, then let me select all this and try to drag it up. Yes. All right. So let's go ahead and make our number line. X values, negative 3, 1, 3. Doesn't have to be perfect. If you can't really estimate though that well in terms of the numbers, actually mark every value from -3 to 3, just in terms of like ones. Okay, so we have our number line with marked boundary values. Okay, from our original inequality, we see that there is an equal sign in here. It's essentially a greater than equal to sign, right? So that means we are going to include the boundary values. So put point or bracket for interval notation. All right, now so number line with marked boundary values and test points. All right, so let's choose x as -5, x as 0, x as 2, and x as 5. So that section 1, section 2, section 3, section 4. Test all your sections. Okay. Again, we're going to use the shortcut here. Use factored form of inequality to check signs. Okay, so our inequality, we had x minus 1 times x plus 3 times x minus 3 greater than or equal to 0, right? Original factored inequality. So essentially what we're saying here is that we want this side here, the left side, to be greater than or equal to 0, so non-negative. So the equal to 0 part, that covers the boundary values, putting the points there. And then the positive stuff, that's when we have to test and see when I plug in my x values, does it make the inequality true? Okay, so when, mark this and move it down, so have some room. Okay, so here we go. When x is -5, look at your shortened version here. If I plug -5 in for x, I get a negative factor times a negative factor times a negative factor. Negative times negative is a positive. That times another negative is negative. Okay, so if I get a negative on the left-hand side, is this inequality true? No. So I don't shade it. When x is equal to 0, I get a negative factor times a positive factor times a negative factor. So that's negative times negative, which is positive. The left-hand side is positive inside of this section. So I will shade it. in that section. Okay. Repeat when x is 2, positive, positive, negative. That gives me a positive times a negative, which is a negative. So I don't shade the section between 1 and 3. When x is equal to 5, positive, positive, positive. So the left-hand side is positive there. So we do shade that side as well. You are asked for interval notation for this particular problem. Let's do the solution in yellow. Okay, so essentially -3 to 1, both boundary values included, union 3 up to infinity. And remember, infinity is never included. You can't touch it. Okay. That concludes the homework alternate chapter 7 assignment. Please let me know if you have any questions about it. I'll be giving you guys some updates closer to the end of the week. And yeah, we'll go from there.